Okay, so good afternoon everyone and welcome back to COMP1531, our second lecture for week 1. While we are waiting for maybe a few other people to join in on the live stream and maybe in person, there's a quick quiz just to recap some of the things we have learned on Tuesday. Just 5 questions just to get a sense of where you are with JavaScript. So you can just scan that QR code or just use that tiny URL link that is provided on the slide. It may not appear on your normal lecture slide that has been posted because that was done yesterday. But yeah, if you can just scan that QR code, and while we are waiting, maybe you just want to quickly answer 5 simple questions. Yeah, right. So I think we can get started now. How many of you got a chance to review some of the things we did on Tuesday or practice some JavaScript over the past few days? Anyone? Yeah, 1, 2, 3. Some of you may have had your lab session already. So that's pretty much getting started and also practicing JavaScript. Those of you who haven't yet, not a problem. You have this week, attend your lab session, and I think starting next week you should be up to par of what is required of you, at least for the first iteration of the course, right? So the first assessment of the course. So now let's just quickly get a sense of where we are or the class is at. So it was just a simple form where you answered a few questions. 47 of you have submitted your answers. Let's see. Yeah, so let's go back to the question. The first question was, what will this statement print? So we have a constant declared, right, and assigned the value of 18. So the name of that variable is age. And then we're trying to print that variable. Quite straightforward, isn't it? So the answer is what, A or C? C, right? Because as I said, even though we have not defined the data type, JavaScript tries to help us out by automatically detecting the data type. So since the value is not enclosed in double or single quote, it assumes that it's not a string then, and just assumes that it's a integer value, right? Let's see how everyone did. Well, there are few of you who got it wrong. 3, okay, not a problem. But yeah, just be mindful of that. The second question, what happens when this piece of code is run? So we have a constant score declared with the value 90 assigned, and then we try to modify that to 100. Right? And the correct answer is C, because you can't modify a constant. The rule applies to other programming languages as well. I hope all of you got, okay, there's one extra person this time around who got it wrong, right? So you won't print 100 because you're trying to overwrite a constant value, so it throws an error. And there are some who said nothing happens. Nothing happens means just the code just runs and doesn't throw any error, right? Maybe it doesn't display anything, which is also incorrect, right? So the code won't even compile. The third question, what will this print? Right, so we know the indexing starts from 0 for an array. So items element or index 1 is actually element number 2. Right? So the first item there is index 0. This is index 1. So the second item is what will be displayed. So the answer is B. Let's see where we are with that. Right, so most people got it right this time around for that one. Question 4, what does this code print? Slightly getting more advanced. So we use a for loop, we go through that items array, and then we say item of, right? So in the for scenario, in a for loop, you can say for in or for of, right? In this case, we're doing off. So what does off return? What does it provide us? The values of the in the array, right? If you do let item in items, then it will return the indexes, right? So 0, 1, 2. But in this case, it will return the value, which is x, y, and z. And where are we with comprehending that? Again, most of you are on track. There are a few who probably need a bit more practice. And then the last question is, what will this print? This time, it's not an array, it's an object. It's a car object with an attribute brand, and that's assigned the value when the object is created to Toyota. And then we try to set the value for year, right, for that object. Do you think that will work? Yes, right. In JavaScript it would. Maybe in some other programming language it won't be able to identify that attribute, but here it does. So that object, JavaScript, as I said, is quite flexible. So it creates that year attribute and assigns it the value 2022. So when we run the code, it will still display. It won't throw any errors, right? So that's what you get as your answer. And we see that this time quite a few got it wrong, maybe because of your knowledge of other programming language. But like I said, JavaScript sometimes is weird. It allows you to override things. You don't have to specify data types and things like that. It assumes things as well. It tries to be flexible. So sometimes it works in our favor, sometimes it may not, right? So just be mindful of that. And that's why we will at some point find it will give us errors. Okay, so I think a good start, at least more than 80–90% of the class has been listening. If you recall, in the last lecture, we kind of missed out on discussing the last few slides, right, on JavaScript. So we didn't go into detail of the objects. I won't open the slides. Probably I'll just do some practice with you, practical hands-on. So what I'll do is, if I see that's not there, just me open VS Code, and let's recap by writing some code, right? So cd student. Okay, so this is the directory which has my lecture 1.2 code that is here locally on my laptop. So I'll open that. Right, so those may look familiar to you now. I'll open a new terminal, right, and let's create a new file. Okay, let's call it revision.js. Okay, let's create it here. Okay, now let's start with arrays, right? So let's say we have an array let's call it data, and let's put, sorry, that's not an array, that's an object. Let's put some mixed data types. Suppose that is some other value in that, right? Now, if I want to display the contents of this array, what should I do? Just console.log. And can I just do data? Will this work? Okay, let's try. It does, right? So it's actually not displaying exactly just the value space. It's displaying the entire array object, right? So the entire array. So the array structure is shown. So you can actually comprehend from that, okay, that's an array, and those are the values in the array. If I just want to display the data from the array, right? Just the name and some few numbers and string that is there, probably I can go through the contents of the array, and maybe I can just use the for loop, right? Let each item, should I use as, for or in? Off or in? Off, right? And then data, and then console dot log, and then I can just display. What should I display? Data and that item, right? Because is it? Can I just type item here directly? Yes, right? Right, now it's showing me the specific values in the array, right? If I instead want to get the indexes, right? So I just suppose want to show the indexes, I would use in, right? Why is it auto typing for me? Okay, now what do you think that this loop will display? 0, 1, 2. Yes, right? So the first part was displaying that the contents of the array, the values. The second loop is now, because I'm using for in, it is showing me the indexes.
Is there a reason that we don't need the semicolon after, initializing the array?
Like I said, it's very flexible and user-friendly JavaScript. So if you miss it out, it's still fine. It's not very strict on certain syntax requirements, right? So it helps us out with that. But it's a good practice to always put it in TypeScript. You do have to be mindful of some of those certain coding syntaxes, right? But here in JavaScript, like I said, if you miss it out, it's totally fine. Is there a way where I can use this same for loop, which is showing me indexes, to show the contents of the array, the values?
Indexes, like start of bracket.
Yeah, so I just can do, why is it data index? Right, so I just clear that. Right, now I'm getting the values. So now with arrays, there's a flexibility. You can use a for in, or you can also do a for, what's the other one? Off. Okay. Now, suppose if you just wanted to show a specific, let's say value only, just the name out of there, because at the moment it's looping through and displaying everything for me. Suppose you just wanted to extract a specific value, how would you do that? If I just wanted my code to print Shavin, suppose. Yeah. All right. Okay, so as long as I know the location of that item, right? One of the ways is, for example, just refer to it directly using the index, right? So the name is at index 0, right? And I can only display the specific element for the user, right? Can I modify that element? Can I do data index 0, which currently has my name, to maybe one of the admins of the course, their name? Will that work? Yes? Why did that work, even though we defined that array as a const?
Const would only have problems if I try to redefine data itself. For an object it would be a subfield, or for the array an element in the array.
Yes. So const is basically what it restricts you from doing is redefining that object or redefining that variable if it's a variable, right? Here it's the value of the object, so there's flexibility for you to modify that. But if I try to redefine that object like that, okay, that's when that const comes into, becomes alive, right? It tries to restrict you, give you errors, right? Any questions?
Would you still be able to redefine index 0 to a different data type? Like instead of a string, you do data 0 equals and then...
Yeah, sure, you can, right? So his question is, if you just want to change just the data type, because the array here can be a mixed data type, so if it becomes 45, right? Still works, right? So values you can modify. Okay, now towards the end of Tuesday's lecture, you'll find a few slides that cover objects. Now objects are also a data type, right? Similar to arrays, but what it has is basically, instead of indexes, you can have keys, right? So for example, if I define an object, let's say student, right? And then I could have student name there, right? Age, and then suppose that person got a mark, so that object, maybe let's put 89. Right? So that's an object. Now if I do console.log and just try to print student, it should display what? The whole object, right? It does, right? And this time you see, just by looking at the output, we know it's in curly braces and not in rectangular brackets, so it's an object, right? Now if I just want to display the name of that student, right, I can use the object and the dot operator, right, and the attribute, let's say name, right? There's another way to display the name or access that particular attribute of that object. Anyone knows? Because we don't have indexes, we have keys, right? So similar to how we refer to indexes in JavaScript, arrays, we can just refer to the key in this case, right? Student name, right? So now the second output that's there is using that key of that particular object, right? Using the rectangular brackets. We can also modify things, right? Same rule applies. We can modify the values even though it's defined as a const, but we can't modify the object. So if we say student equals 25, that will not work, right? But if we say student.name equals whatever, that should work. Let's try with first displaying this name. Let's use this particular notation. Remember, you can use them interchangeably. It's totally fine. But as good programming practice, you may want to just stick to one. Right. Semicolon is not mandatory. Yeah, but yeah, so you get the results. Now that's one object. Can we have a number of objects in an array? Like suppose if your class definitely won't have one student, you might have maybe 5 students, right? How do you handle them? right? So you can do something like this, student 1, student 2, just change a few values, right? Now let's create an array called student data, right? And then it will have student 1 and student 2. Right. Now if I do console.log, not student because you don't have student anymore, student data, what do you think will be displayed? Yeah, so let's see. Yeah, so we get a list of objects, right? Now, if I want to just display the names, what can I do? Right? Student data dot name. Because there are now multiple objects in a list or in an array, so we have to loop through, right? So we can do for let item, or do you use in or for? Of, sorry. Of student data, right? Let's go step by step. If I just display the item, what do you think will display this time around? Right? So it displays one object at a time, right? So if you want to show the name of that, just the name attribute, you can do something like this. So first time, the first object gets copied to item, and then item.name is displayed. So Rani is displayed, then in the next cycle of the loop, you get Emba assigned as the name attribute, right? So now I run that, I only get the names. Now what we can also do is go a little bit more advanced. We can write a condition just to find out who passed and who failed, right? So we can say in the loop, if item.mark greater than equal to 50, you display, okay, let's do that. Who passed and who failed the course, right? So if item.mark is greater than equal to 50, and we want to display something along the line of, suppose Rani has passed or Rani has failed, right? So I'll do system, sorry, mixing Java with JavaScript. Log, okay. So how can I display the name of the person? Item.name. Then we recall the concatenation operator we did last time. Has passed, right? Why has passed? Because if the condition is true, we go into the first part of the condition or first few lines, right? Else, let me just right, has failed. Right? So we expect Rani to get a pass and Ember to get a fail. Because we are iterating through or going through the student data array, right? We are sure that both the students will be considered. Let me just clear the screen and then run it, and then it gives me the appropriate results. Now from here things can get more complex, but that is where we'll stop now. and let you reflect on it a bit. If you have any quick questions, you can ask. There is source code posted already. More examples of this. You'll notice for objects we have more 1, 2, 3, 4. For arrays, comparisons and all those, there's quite a lot of examples there. There's some additional resources also on the course website. And of course, you have your lab activity, which you can help you practice JavaScript, right? So that is just trying to close off Tuesday's lecture. Right? Now, today we'll talk about Git. So let's take a 1 minute break just to give you some time to reflect and breathe, and then let's start with today's lecture properly. In the meantime, if anyone has any questions, please feel free to ask. I think the slides are already there. I'm not sure if they are shared or visible, but if you go to the course website, I mean, I was able to view it. So if you go to slides and code, if it's not linked here, if you directly click on lecture slides SharePoint, I hope you are able to see it there, right? But if you can't, then definitely at the end of this lecture today, I'll make those available. Okay, let me just check online. Yeah, there's a request for original PDFs so that we can make notes. I can't save the current. I mean, are you able to download the slides from there at the moment? If that is disabled, I'll just double check and make that enabled, right? It's just someone on the live stream who's not able to download the slides. Okay, so now we have, we are familiar, okay, that we are going to use JavaScript for this course to do our project. We also know that we need a development environment. So to help us with that, we'll use VS Code. Now, why do we need to learn Git? That's the thing that we're going to discuss today. Anyone knows why or where Git actually fits into this puzzle? Can you survive with your project without using Git?
Version control.
Okay, version control. Why do you need version control? Can't you manage your own versions locally on your machine? Or can't you use maybe tools like Google Drive? Put your version there and your friends can take things from there, put it back with their updates. Okay, so the problem is, if it's a simple project, right, and there's only 2 people maybe working together, you may be able to escape without Git. You may be able to share your code with each other easily. But for large projects, in your case, you have like 5 members in your team, right? This can become problem, right? And we have multiple people working at the same time. Maybe they won't be available to work together at the same place. So some will want to work on the project from home, from their own device. There might be another person who wants to use the CSE lab. Maybe you want to do things from a coffee shop, right? So it becomes very hard to keep track of what is happening, right? Simple file sharing becomes a problem, right? Because someone has progressed far on the component, but still it has a lot of bugs, so you can't actually use those components. So it becomes very chaotic. Now, at first glance, you may think that, okay, I can use Dropbox, OneDrive, or Google Docs because they allow file synchronization, right? I can do my, my part of the code and just push it online and just say this is version 1.1. Someone else can take that, do their part, and upload it, make it version 1.2. right? So that is if they work sequentially one after the other. But what if they want to work at the same time? So you have version 1.1 and then you think, okay, we only have 2 days to finish your coding. So you'll work on your part and your friend can work on his part or her part at the same time, right? When you push your versions, which version does it become? 1.2, 1.3, 1.4, right? So it becomes very chaotic. So that's why Google Drive, Google Docs or something like Dropbox is not good for complex software projects, right? Many people who want to work concurrently and at the same time. The other reason is they're not designed for programming, right? So for programming, you need a proper IDE. A lot of things is done offline, right? So when you only push your work, that's when the other person is able to see what changes you have made, right? And Google Docs and many of these drives, they are online systems, right? You can work collaboratively with each other, but you can't run compile code and things like that there. No, you can see, no is it very helpful for programmers. And also for large scale collaboration where you may want to give feedback, advice, revisions and things like that, there's only the comment section in many of these tools, but they are not very suitable for multiple team members working on the same time, sharing their opinion, accepting part of the updates and then rejecting some and so on, right? So it becomes very problematic. So that's why we need Git, right? The two main features that it can support is version control, like one of you has mentioned, right? You can track changes of your code. So basically it's a time machine. It gives you a log of who did what and when was that committed or updated, right? So you can go back into history to see what happened. And also you can do concurrent programming. You can take a version and people can create their own branches and work on their own branches, progress those branches, and when they are happy to merge, there are features and functionality that allows you to merge and synchronize those files, right? So the tool itself can help identify what are the differences, what are the similarities, and whether you want to integrate and accept those changes easily, right? It can be done quite easily. So we'll see some examples of that shortly. Now Git is the software that we're going to use. So basically that is what is going to help us with all these version control and collaborative programming, right? It's specifically designed for managing software engineering projects, right? It allows distributed version control. So this is the setup that probably you'll have for your COMP1531 project as well. So you'll have a version that is there living on the CSE server, but each group member, user ABC, will have their own version running on their local machine, right? Doing their own part, contributing towards the project, and then syncing it back to the main version that is there on the Git. Now, just to avoid some confusion, you may have come across tools or platforms like GitHub, GitLab, Bitbucket. Now, what are they and how are they different from Git? Right? So Git actually is a command line program. They do have a visual or graphical user interface, but there are some limitations of that. These tools, GitHub, GitLab, Bitbucket, basically are software or interfaces to Git platform, right? So they allow you to use a web interface to actually carry out those Git operations, right? So what we have for this particular course is GitLab, right? Git is the base architecture, and then these platforms basically, even though they may vary in interface, allows you to carry out similar functionality like version control and collaboration. Okay. In this particular case, in this particular course over the 9 weeks, you'll experience 3 types of version control, right? The 3 key stages you'll encounter. One is version control as a single machine, where basically the work is basically your work. You don't need to share with others. For example, the lab, right? So you'll manage that. There will be version control across multiple machines. So maybe you are not using a single machine. That same task that you are performing is on multiple machines. You might use your own laptop at home doing your lab activity, but when you turn up in the lab computer, in the labs, you might use the lab computer, right? So you are the same single user, but using two different versions, right? Or two different versions of the code can be living on two different devices, right? So what you did in the lab computer might not be synchronized with what you have on your own laptop, right? So you have to manage that version control as well. And the third type of version control that you will manage is amongst your group. So you as a user are doing something on your own machine, but there's another person who's working on that same project on their own machine. So you need to merge your updates and contributions as well, right? I will visually demonstrate these three variations. I think that will make life a bit easier, right? So on your single machine, right, assume this is the your local machine where you have, you don't have Git installed locally. You have controls for that, but your actual task is living on the CSE server, right? And this is your current working directory in your machine. All you need to do is interact with that. You don't need to worry about anyone else, right? So you only have one version. You pull that version and you work on it. You clone that. You add, you commit, and whatever changes you make, you push it back up, right? Now to make that work, those are the commands that you have to remember. To initially set up that you have a version on your machine, you need to have SSH keys, right? And the reason we need that is because you don't want to log in every time we want to refresh our work, right? So once you set the SSH key, this information is provided on the course website. There's a getting started video. You don't have to log in, log out of Git every time, right? And then you just clone the version that is on the server, and then you can start working on it. If you want to compare your version with what's on the server, you can just type the command git status, right? And then you can add things, you can compare the differences, you can commit, and you can push, right? Now, add, commit mostly happens, the repo or the changes to the code is mostly on your own machine. Only when you push is when it gets pushed to the server, right? And if you want to retrieve something, you do git pull. Right. Now, let's just see that first instance in action, right? So what I'll do is, in the lectures section on GitLab, I'll create a new project, right? A blank project, and I call it lecture demo, right? It gives a slug by itself, basically a short name to refer to that, right? I'll keep it internal, so if you want, you can also view that project, right? And then I don't want any complex settings there, just have a README file. It's good to have a README file in a project, so if someone visits your project, right, they know what it's all about. So I'll just click create, right? So if I go in the lecture section again, you'll see that was what I pushed last on Tuesday. This is what I created just now, right? And this is the README file that is automatically generated. Now this is living on the CSE server on this URL. It's not on my machine. So if I want to write code, right, I have to get that on my machine first, right? So first, what I'll do is, I want that to live on my desktop here. That's my project from Tuesday. Now I want to pull it or clone it here in this particular directory, right? So like I said, some command lines, right? So currently my present working directory is my desktop. That's my username, desktop, and then that is the folder I am currently in. At the moment, if I list what's there, it shows me that that's the folder that's there. Now what I'll do is git clone, right? That's basically just a setup process to get that project locally on my machine. Now to clone it, I'll go to the code section and I use clone with SSH, right? If I do with HTTPS, I can download it as a zip file, but it's always better to use the command line because it's more powerful and more stable and more useful because you can use that approach across any device, right? So I'll copy that, git clone, right? So it's cloning my lecture demo. Now if I do list, you see I have the first directory, the project that was from Tuesday. Now I have lecture demo as well. And just to visually confirm that lecture demo is now living on my own device, right, on the desktop. Now let me open that, right? So I use code, lecture demo. This will open it using VS Code, right? I'll minimize that. I trust it because I created it, and this is the README file that was automatically generated. Right? Now let me just change that. Update, and I just want to be lecture git demo week 1. Right? I'll save it, Control X. Now if I go to view the terminal, I'll just open the terminal here, right? I do git status, right? It now tells me README has been modified, right? Before modification, if I had run git status, I should have, then it would have said that your current repository is up to date, right? But now since I've made the change, it has been modified. Right? If I suppose, so this is only happening locally, right? I've saved it, and you see the README has changed. If I go and see the server end of things, if I refresh, you see the README is still the same, right? It's only locally been changed. So what is happening is this, right? So that's just being cloned to my normal working directory here, and I'm pretty much just working in my own directory, right? Remotely. Now, if I want that change to be reflected on the main repository there, what should I do? Anyone wants to suggest the command? Stage, right? So what's the command for that? I mean, there are many Git commands, right? Some very advanced, some have flags and other things. We're going to stick to just a very basic, simple subset of commands just to get started this week, and then we can go and dive deeper into the advanced ones. So from this list, right? So I did git status currently just to check what's the status of my project. If I do git logs, sorry, I should open this one. I'll frequently clear the screen so that whatever is displayed is just towards the top of the terminal. Git log, right? It just shows me the first initial version of the project that was created, the initial commit, right? So that's the original version. It doesn't tell me that there's been any updates to that anymore, right? That's the only log, the last commit that happened. If I just explore things a little bit, that's what it means. Only the repo was created, the initial commit where I created the README. If I want to visualize, that's just one commit that happened on the repo, right? So I'll just go back. Now back to the question, how can I push my update now? Because you'll be doing your labs, right? You'll be cloning things onto your local device. You will make changes, and then you want to push it up so that the it can be auto-marked. So once you've made the change, what do you do? Git add, okay. So, sorry, always try to use VS Code, right, at the terminal there. So I do git add, and then we can add one file at a time, right? Or we can add all the updates we have done at once. We can use the dot, it will add everything. If we do asterisk, it will do the same, right? I normally use dot, but for just a beginner awareness purpose, I'll just add readme there. So do you think the update has been done now? No, right? It just puts it in a staging area. So the best analogy I could find to maybe explain this is my working directory. Suppose the server is somewhere there in the cloud. When I do git add, it just, in the package, okay, it just adds that file. Just like if you want to deliver something via courier, you have a box, and you add files to that box. So that's items to that box. So git add is adding that to that box, right? Let's suppose add another file, new file. Let's call it project dot. Sorry, should click on this project.js. Right, I'm going a bit slowly because for some of you maybe it's the first time, and let me just do a console.log. Sorry. Hello everyone. Right, just keep it simple. Right. So I added readme. If I do git status, right, it shows me now readme was modified because readme file existed, remember, and then there's a new file that's added, that's project.js. What I'll do is add this file too, right? So I could do git add and then put a project.js in the package or in the box, right, for delivery to the CSC Git server, or I could just put dot, and whatever has been modified or added will all go through at once, right? So everything is now put together now. Now after I have that sorted, before I send it out, I have to paste the labels, right, or some information of what it is or description of it. So that's when the next command comes, that's the commit. Right? So you say git commit and sends a message. So if someone goes to your project and look at what changes have been made, they can know, okay, that was the initial commit. Next, maybe readme file was updated. Maybe that's what you want to share with your colleagues, right? Or just for your reference, what change has been done. So you can do that, right? So let's do git commit message, and then readme has been updated and project.js has been added, right? You can write a few sentences, I mean a sentence or two if you want, but you have to keep it descriptive, right? Just for beginners, I'll just write whatever there, but don't just say update, right, or fix. Right? Try to explain so that if someone wants to know what was done in that commit from the message itself, they'll know what happened, right? Right? So it tells me there are two changes, insertions and so on has been considered now. So it's now packaged with a label put on it with a message. Now I can do push. Push means go up into the cloud. Right? Now let's see what has happened now. Right? So you see readme has been updated. That's the message that came through. if I just go back just to the repository, right? Now you see the text has been changed. Now you see project.js has been added as well, right? From local to now in the cloud, right? And I can now see visually as well, if I go to this particular project lecture demo, two commits now, right? And then if I look at the repository graph, you see it has progressed. So the version has progressed from the initial to something more advanced now, right? So that's the sequence of commands that you will use. Anyone has any questions? Yeah.
In this course, we recommended to push after every commit, or is it fine to make multiple commits before pushing to the...
I think it's better as beginners to do after every commit, but make sure the commit is significant. Don't just put one dot or semicolon and start pushing things, right? So you don't want to have a lot of commits there as well. So just try to create that balance, right? And you'll be marked for the descriptiveness of the message as well, right? So for your assessments, just make sure it's not something weird. It's informative, right? It's not too long as well, right? But a sentence or something of 7 to 8 words should be fine. Right? So that is a situation where you're using a single machine, and next time you don't have to clone it because you're using your own machine and you push that code. So the code is still, the copy is still living in your working directory, right? If I just quickly go here and just clear this up, right? And I just do git status, right? So it says your branch is up to date with the main branch. Right? Now, it's always a good habit before you start, because you will be sometimes working on a group project, or I think for the project itself, it's always to start with a git pull, right? Even though it says up to date, right? Because just in case if you were on a different computer and it has a different version, right? And that person has made some changes, or you have made the changes using, for example, the lab computer. Maybe I can simulate that here, right? Can get tricky, but just bear with me. So suppose this is my laptop. I have another folder here, and I say same student 1, but I just say in the lab, right? So on my laptop, I have that project. In the lab computer, when I go to CSE lab, right, I don't have that, right? So what I can do is clone it in the lab computer. What I can start off with is, so now we have the lab, student 1 lab computer, so cd student and lab, right? So now I'm focused on this place, this location, and then I'll do git clone, and then let me just get that project. Okay, so now you see on the lab computer there's a clone of that project, and they are on the laptop. Even though I'm just trying to simulate it using folders, this will be the same thing that will happen when you suppose don't bring your laptop to the lab and then use the lab computer, right? Now what we'll do next is just open this one, the lab instance, right, of the code. So code, sorry, what's the name? It's lecture demo, case sensitive, so just be mindful of that, right? So this is here. Close this. I'll go to README, and I just put some additional information. Changes, added project .js, right? Now, this is done locally on the lab computer now. My own laptop actually is not aware of this, right? So my own laptop, the project there on my own laptop is not aware of it. Likewise, here, this change that I have made, if I go to lecture demo, right, the README file is also not aware of that, the version that is on the server, right? Because it's the same user, but on multiple devices, right? Because it happens to us, because sometimes we work from home, so we don't take this laptop home, we use our home laptop to do the task. So the version there is out of sync with the version that's here, right? So that can happen too. So it can happen to you as well. So single user, multiple machine, that's the scenario we are trying to simulate. So I've made this change. Now what I'll do is, I'll do the same, right? I'll do git status. It tells me that README file has been modified on that lab version. I do git add, right? I can put README, or I can just use a dot, right? So I've put that for delivery now. Then I do git commit -m, and the message is included track changes section to README, right? Right, so I have put a label there, right? There's another command called git diff, right, which I intentionally skipped. So we have git status and git diff, right? Diff basically is, anyone knows what it stands for? Difference, right? So if I do git diff, right, it will tell me, wait, let me clear, okay. So if I do git status, nothing to commit, okay, I should have done that before I have made the change. Okay, if I do git difference, it will tell me the exact difference. Okay, I'll just do it another example. I'll show for git status and git difference what's the difference. So now, since I have added them, I'll just do git push, right? So now that has gone into main. So from the lab folder or lab project that was living on the lab computer, it has gone onto the CSE server, and now you see the change section has appeared. Now if I want to see what's in my laptop version, if I open my README, let's see, right? It doesn't have that change. See, it doesn't have the changes section. So that's why git pull becomes very important. So whenever, let me see, lecture demo. So this is living on where? Present working directory. So this is the laptop version, okay. So if I do git status, right, so it tells me it's up to date. If I do git pull, right, so now the changes have come through in my the laptop directory where my repo is living as well. So now git pull has pulled the changes from the CSE server to the to this particular directory. Okay, so what we have been doing is basically this, right? I hope you are familiar with all the commands. I'll show you git difference shortly. So when you are working on a single machine, nothing to worry about, but it's a good idea always to pull, right? But when you are working same person on multiple machine, right? Maybe one in the lab, one your laptop, or maybe you have multiple laptops, it's always good to pull, because you might have an outdated version of your code in one of the working directories. So always pull before you start working on it, right? So we'll take a short break now, because I think probably it has been intense for some. 5 minutes break, and then we'll talk about merge and how to work with multiple users. In the meantime, if you have any questions, feel free to ask. On the screen is just in the break I've written some very basic code. So suppose you are working on a project and then your role now is as student 1 to create the function called add, and then the corresponding lines of code just to compute the sum of two numbers and then display the results, right? So you've made those changes and you are ready to push it to the server because that was your responsibility within the group. Now if I do git status, right, it tells me that project.js has been modified, right? So it tells me which file has been modified. If I do git difference, it tells me exact parts of the file that has been modified. So that's the only difference, right? So if you have want to know just the file names which have been touched or modified, you do git status, it gives you a summary, but if you want to go into the details, you do git difference. It will exactly tell you the line numbers and so on, right? So for now, I think that's basically all you have to remember. Yeah, and then the procedure is same as what we discussed before. Once you have updated or written your part of the code, what's the next command? You add it for delivery, right? Then you label it using commit, appropriate message, descriptive message, and then push it to the server. So the sequence is add, then commit, then push, right? So I'll do the same. Sorry, focus is in the wrong place. Okay, so just clear this so that we move up. So git add, if you want everything to be updated, in this case even though it's just one file there, and then git commit minus message. Can anyone suggest a message we can put? Yeah, so implemented add function, right? At least informative enough, and then git push. Sorry. Okay, so let's see if that has gone up here. Lectures, lecture demo. If I go to see, just updated a while back, and you see the add function is there, contributed by that particular student in the output, right? And also, like I said, you see the tree would have grown. What I mean by that is just give me a moment. The number of commits have now gone to 4, right? So we have initial commit, then we added the readme, and then the track changes component in the readme, and now we have added the add function, right? This is what the graph looks like, linear, right? That's when a single person is working on a project. So now we'll just change focus to the next part of the lecture. There's only a few slides, and then we'll get into the practice as well. And in this one, we'll see how Git is used for team usage. So here, what new concept has been introduced is branching, merging, and merge requests, right? So the main reason Git is more useful and powerful is because it allows people to work together, right, collaboratively. So you might have the master branch which we had, and we were progressing nicely. But if you have more members in your team, then you may want to branch out and work on certain functionality on your own, right? And before you could commit it, maybe the other group member extracts a copy of the, or clones a copy of the repository and starts working on that, right? So things become a little out of sync, but at some point by the due date, it has to be in sync again, right? So when you try to take on a feature independently, that's called branching. So what we learn now is the command that is used to create those branch. You can actually do it using the interface as well, but like I said, it's better to use the command line. The reason is because then you can use it across any platform you are using, right? Because if you are using the interface for GitLab, it will look different to the interface for GitHub or Bitbucket, right? So all these tools may have slightly different interfaces. So it's better to learn how to do it using commands first as beginners, but then later on you can also use a combination of both. In real world, software engineers use both the commands as well as the interface, right? And then when you branch out, of course, you have to merge, and then you can't just merge by yourself. It's actually not recommended. The reason is because your code may still have some bugs, right? And usually you want to have your master branch clean, right? Or working properly all the time. So all the debugging issues can be handled within your branches, and only the working version should be, or functionality should be pushed back to the master or the main branch. So that's why we create merge request. Merge request basically allows you, before you merge your code into the main branch, an intermediate step where someone else from your group can review what you have done and then say approve, yes, we can merge it. And there's opportunity also to communicate and other things which we'll show later on. The main idea is you can share knowledge, improve code quality. Maybe your friend would suggest, no, don't do it this way, use a loop structure, or instead of for loop, try to use a while loop. So those suggestions can happen during merge request, and you improve your work on the branch before it gets finally pushed onto the master or the main branch, right? And it also helps you to catch bugs early, right? So there's a guide, Atlassian guide, which is provided in the slides. When you click on that, it takes you through a lot of commands and a lot of functionalities of Git, right? I've already shown you the visualization of your repository, right? It's more a tree-like structure, and basically it's a lot of commits, right? And then you have branches where you branch out and then you merge back to the main. Okay. Now the command to actually create a branch, so suppose you have another group member who wants to work on the project, you use the git checkout, right, command. So we'll do that, and because I'm here alone and I should have brought a separate machine, but I think you people would still be fine. So suppose this is my group member here. I'll create a new folder for him or her, and whatever lives in this particular directory, basically let's assume it lives on the laptop of the other person, right? So student 2, so not student 1, this is student 2's laptop, right? So he has joined your group, or she has joined your group. It's currently empty. They will go to their terminal or power shell and so on, wherever that is, cd student 2, right? So what that person will do is git clone, right? They want to have a version, and then they want the most recent version, because you have already done your part, which is created the add functionality. Maybe their task is to create the multiplication functionality, right? So we'll get the SSH option from there, paste that, so git clone, did I make a mistake? Oh, it's not clone, it's glone there, so typo. CLONE, right? So now you see this is your friend, student 2 or group member. That's their laptop, which now has lecture demo. This is you, student 1. Your laptop also has lecture demo, right? They have just cloned the most recent version. So what I'll do is just open a separate VS Code interface for them, lecture demo. Right? And I'll not need that anymore. I'll just minimize that. I'll just open I trust and view new terminal. The reason is I just want to know if I'm typing things in the right place. So at the moment I'm on student 2's laptop. Okay. Now if I want to create a new branch, because I'm now tasked with writing the other functionality of the project, other feature of the project, right? I could do it two ways, like I said. One is using the graphical user interface, right? You can go here and do new branch. But for beginners, at the moment, we don't recommend that, right? Let's get more familiar with the command line first. So git checkout, you'll see at the moment, my branch here is showing as main, right? If I just write the command branch here, git branch, it just says there's only main branch, right? Now if I do git checkout and then -b for a new branch, you want to give a name to the branch? Anyone wants to suggest a name? So the main is basically the main central branch. Then each group member will have their own branch, or each programmer will have their own. Student 2. Okay, let's just keep it simple, right? Student 2, right? So now you see, as soon as I create the branch, it automatically checked me into this particular branch. If I use the command git branch, right? So there's 2, and green is highlighted because I'm in that particular branch. And just to confirm that it has worked well, now you see if I click on main, there's, wait, oh, it's not showing me here. Why? Yeah, so remember, student 2 is currently working in the local directory, local machine, right? He hasn't pushed the update that he has created a separate branch now and working on a separate branch. So that CSE Git server doesn't know about it. Neither do you, student 1, know what the name of the branch is, right? Only when they'll push, then you'll get that update. So before we push, let's just implement quickly. Let's do the subtraction function. A minus b, right? This, just to differentiate, I'll just put here, sorry, done by student 2 laptop, right? So this is group member 2. Same things here, to let difference equals subtraction of, just do x minus y, so you put like that, right? And then displaying output, difference is difference. Okay, I'm happy with that. Let me just also update. Suppose the group member also said added subtraction functionality, right? Okay, it's just clear, and then node, and then just run this code just to see if it works before I push it, right? So it works. It says difference is 5. Right? Still on my local machine, still on student 2's local machine. Any questions, confusions? No? Okay. Next, I want to push it up. Right? So I do git add, right? Always a good idea to know what files have been updated, and you can sometimes want to just update those specific files, but in our case we want all, right? Because we updated both readme and project, but you can write their names side by side there as well. So they have been added. Let's label that git commit -m for message, and the message is, let's say, added functionality, right? Okay, so we put the label, then push. Right? Let's see. Right? It says to push the current branch, set the remote as upstream, use this, right? So what it's trying to do is, it's not able to push that branch, right? So what we'll do is just use this line of code that is provided, and now it has finally pushed it. Because the reason why it's not able to push it upstream is because there wasn't a branch to push that into, right? Because you are working on student 2 locally, it couldn't find student 2, right? So the error message itself was informative enough that it could not push it upstream. You just copy that same code, right? Don't worry about that. It only happens just once when you create your own branch, and then the rest of the time you are going to use that same branch for writing your code. So it has gone up now, and let's double check. Right. If you go to main, now you'll see student do branch existing there now. So the work of your colleague is now sitting on the Git server, right? Now if you go to project.js, I still can't see the subtraction function. Why? Huh? Yeah, so what has happened is now, right, at this point, right, you decided to, your group member decided to implement a feature, and they have created a branch, right? And when you go to main and you see what's there on main, the update is not there, right? The update is on the other branch. So if you want to just manually, just for curiosity's sake, want to see that particular branch, because you'll have permission within your groups to see what your colleagues have pushed. So you'll see that it is now sitting on a separate branch. Right? So that's what branching is all about. Now you can create many branches, right? And you can do many commits. But don't overdo things. There's a requirement in the project. Each member should have at least X number of commits, right? So just be mindful of that as well. But don't overdo it as well. Also make sure the branch name, the messages are all informative. So we did git checkout, and that's how we created the branch. We used the -b command to create a branch. If you want to go to a different branch, right? Sorry, it should be on VS Code. Present working directory, clear. So I'm in laptop 2. So I just use this command, just present working directory, just to be sure whose branch or where I am, right? So if I want to from here switch to main, at the moment I'm on student 2, I could do git, sorry, tab doesn't work, git checkout and the branch name, right? So now you see I've changed to main, and I can see in main the other code for subtraction is not there. Okay. Now, the next command that we learn is merge, right? So basically there are two situations where you'll need to merge your code, right? One is you have made a change, right? And then you want to merge it with what's there on main, right? So you create a branch, suppose, and then you want to come back to main. It's then when you want to merge, right? Yeah. And the other time is you are working locally, but someone else while you are working has pushed an update, and then you want to reconcile that update with what you are working with, right? So that's the other case that when you want to merge. Now, I'll show you an example of that. Right. So this is git checkout student 2. So student 2, what that student did is created the add function. Now, from student 2, I'll move back to myself, student 1. Right? So at the moment, we know student 2 has created the subtraction function, pushed it on the Git server. Me, as student 1, on my local machine don't have that subtraction function yet. Right? Now, and I'm not aware that he has at midnight done that, right? And it's going to happen to you as well. So what you are doing is basically, right? Without the add function, you realize that, oh, my job was also to write the multiply function, right? So you say, okay, let me add the multiply function as well. Try to be more efficient. Right, multiply, and then A times B. Okay, you are in your own world, and then you do multiply is product. So multiply, and then you display that. Product is okay. So next morning you finish your multiply function and you do node project. Oh, my multiplication works. Now it's time to push, isn't it? Now before you push, suppose you want to just double check if everything was up to date or is up to date, right? Right? Now you get an information that a new branch has been created, right? And your colleague has actually worked on that branch, right? So the main branch is still up to date, right? Now, if suppose that colleague actually merges them to the main, then your main branch will be out of sync with yours, isn't it? So what we'll do is, suppose that happens. So at the moment you can push to main, not a problem, right? Or let me just push it. So suppose you are not aware, your friend has not, colleague has not merged yet. So git add whatever changes you have made, and then git commit minus message added multiplication functionality, right? And then git push, right? So your update has gone, you are done with your part of the project. Your friend, your workmate is not aware that some changes have happened in the background. The main has changed, their main is now a little out of sync, right? So let me just see this one. Yeah. Okay, so that's student 2 laptop. Okay, the next step would be your colleague would want to now merge their version now onto main, right? Now for this, you can use command line, but we kind of recommend that you use the graphical user interface because it allows a little more flexibility, a little more features for you, and allows the communication process a bit easier. So what your friend or group member can do is go to the project. Okay, first they have to push, right, the update. Yeah, so you are on the student branch. What we'll do now is git add. Okay, let me just do git status, whether we have pushed it before or not. Oh, it's up to date. That means we had pushed it already. So if we go here to that particular branch, right? So now student 2, what they can do is create a merge request, right? So we'll create a merge request. Sorry, merge request. Okay, so I didn't select the source. So the source is student 2 branch, and the target should be to the main branch, right? And then continue, right? That person has added some functionality, so we'll keep it to that, right? So they have added the subtraction, remember? You can give some description and assignee, right? So this is you who have submitted the request, and then you can assign a group member, right, who can review your request before merging it into main. Never choose your own self there as to be the reviewer as well, right? Because you have created the code, you want a separate pair of eyes to actually verify that, right? So in my case, suppose I check one of the admins. Do you want your branch to be deleted after it's being merged? Right? For purpose of this project, you can uncheck that because at least we'll have some trace of what you contributed to the project as well, right? And for you as reference as well, how things progressed in your own branch. Otherwise, what will happen is it will try to keep that linear structure for your project, and all the branches that were here and there, once they are merged, they are of no need, right? Even though it keeps a timestamp of what happened when, but it's always good to just keep those branches, right? For a large project, it becomes very untidy, so they select that option, but for us, it should be straightforward, right? So now it says merge blocked, merge request must be resolved. The branch is, one commit behind, right? So what happened was, there was this main branch. One person worked separately on a different branch for subtraction function. Another worked on multiplication and pushed it. Now the person who worked on the subtraction, he doesn't have access, or she doesn't have access to the other function. So when they are merging, there's a conflict, right? So what we will do now is try to resolve that, right? So student 2, git merge the main branch. Remember, this is the second student who does not have access to the multiplication function, right? And then student 2 branch, right? Okay, let me go back to git checkout, git checkout main first. Let's make sure the main is up to date, right? So git pull, right? So that's now up to date. Now git merge main onto student 2. Right? So now it tells me that, yeah, those are the changes. Student 1 has added the multiply function, and all those changes have come through, right, when I tried to merge it locally. Right? So there were some conflicts. So you don't have to worry if this kind of situation happens. All you do is just click and you can accept the changes, right? So just accept. If you leave it to automatic merge, it can work in most cases, but also because of some 9 numbers and things like that, things can go out of place. So it's better to just manually verify what your other colleague is doing, and you can just accept those changes as you go along, right? So now I've accepted all the changes. Let me just tidy things up. Add, multiply, subtraction, add, multiply, and then just move it up here. And then sum product, we don't need the difference, and just looks much more neater, right? Now I go to git checkout student 2 branch. Resolve the current index first. Okay. Okay, so we do git git merge main onto student 2. Fix them in the work tree, fatal exiting because of unresolved conflict. Okay, let's see what happened here. There were no changes to the others. Merging is not because you have unmatched files. Fix them in the work tree and then use git add hint as appropriate to mark resolution and make a commit. Okay, let's commit this. Git add git commit minus message and then resolve merge conflict. And then git push. Okay, so let's see what happens to the merge tree now. If you go here, lecture demo, and go to projects. Okay, so the updates you have actually made on the main branch got directly pushed on the main branch. Yeah, so the updates are now reflected on the main branch. Now the only thing we have to resolve is the merge conflict that happened. Remember the merge request. Let me just clear this. Git checkout student 2. So we have switched the branch. Okay, so the main has been updated. Okay, so I think what I did is I merged the other way around. So instead of mapping the main to the student 2 branch and then pushing it for approval, instead student 2 branch got merged with the main, and then I pushed main directly to the main branch, I mean the main branch on the server, right? So just a slight difference from where we wanted to end up with, but what it did is in the end kind of got us the job done. What I'll do is, I think before confusing you further, I think whatever happened now is a little clearer. I will not confuse you. When we come on Tuesday next week, I'll just briefly clarify how merge requests are approved, right? So you don't have to always merge locally, right? Merge requests can be approved on the Git server directly, right? And you can accept the changes and it gets integrated. Yep. I know it's a bit overwhelming with code and screens changing quickly, but we'll pause here now, stop here now. If you have any questions, I'm happy to help out, but I'll retouch on this for 10 or 15 minutes on Tuesday next week. Yeah.